Alright, Algebra 2, welcome back. In this lesson we're going to go over how to find intervals of increasing and decreasing. And here on this graph, I got a graph of an imaginary journey along the Appalachian Trail. And it shows my hike over several days. So the x-axis represents time and the y-axis is representing the height. And I would like to know, when am I going uphill? With graphs, we always read them going left to right. So imagine that I am starting here on the left side, and I want to know, when is this little guy, as he's going left to right, when is he going to go uphill? So we would say that our intervals of increasing, when is he going uphill? Well, you would give me the time that he's going uphill. So you would say he's going uphill from 1 day to 3 days. So as he travels along here, he's going uphill. So 1 to 3. And we're going to use interval notation. So we're going to put that in parentheses because once we stop at 3, he's no longer going uphill or downhill. He's kind of in between. And there's also another section where he's going uphill, and that one would be this section. And when is he going uphill there? That would be from 5 to, it looks like, 8. So to do that, we put a U. U is like the glue that holds intervals together. So he's also going uphill, also increasing from 5 to 8. And then we can do the intervals of decreasing. So the intervals of decreasing would be on this section, going downhill as it goes left to right. So intervals of decreasing, first interval would be from 3 all the way to 5. So between days 3 and 5, I'm going downhill. And also on this section, I would be going downhill as I go left to right. So that would be from 8 to 11. So I think it helps to think of, a trip like this, and when you're going uphill, when you're going downhill, you got to remember that intervals of increasing means we're going uphill as we go left to right. Intervals of decreasing means we're going downhill as we go left to right. Now we're going to switch to an example with absolute value. So say we have a graph, and let me put my coordinates on here. We're going to have a graph of absolute value. Here's a graph. And let's say that the vertex right here is at the point, we'll just say 4, -2. And again, I want to know when the intervals of increasing are and when the intervals of decreasing are. So the intervals of increasing, when is it going uphill as I go left to right? Well, notice that the vertex kind of splits the graph into 2 sections. So if I draw a line through the vertex, I have a left half over here and I have a right half over here. Which section would be going uphill as we go left to right? If you thought it was the right half, then you are correct. We'd be going uphill. And what time does that start, or what x value does that start? Well, we're going to start at the x value of our vertex. So that's going to go from 4. And how far to the right is it going to go? It's going to continue going all the way to the right. So when we are writing intervals of increasing and intervals of decreasing, we would use the x-coordinate. So this is going from 4 all the way to the right is when it's increasing. When is it decreasing? It would be decreasing on this section. As I go left to right, we would be going downhill. And when does that start? When we write intervals, we always write the lower number first. So it's going to start all the way over here, all the way to -infinity, until we get to, again, the x-coordinate of our vertex. So that's going to be at 4. Notice that the increasing and the decreasing, they make up the whole domain. The domain of this function is from negative infinity to infinity. And it splits apart at the vertex. The vertex is also called an extrema. So this is an extrema, or the vertex, and sometimes we also call this a turning point, because it's where the graph turns, going from increasing to decreasing, or decreasing to increasing. Let's do one more example. Okay, here I drew another graph of absolute value, and this time I have the vertex up here. The vertex is a max, it's the highest point, and let's just say that that point is at negative 5, 6, just to give it some different numbers. And again, we want to know, when is this graph increasing and when is the graph decreasing? So the graph would be increasing. Let's see. Well, again, this vertex splits the graph. There's a line of symmetry that goes right through the graph. And which section is going to be going uphill this time? The left side or the right side? Again, as we go left to right. So if we're traveling left to right, then we can see that the left side is going to be increasing. And at what time is that going to start? Well, it's going to start all the way over here to the left. What's over there? Negative infinity. Until we get to what time? Until we get to the x value again. We're always using that x coordinate when we do increasing and decreasing. So it's increasing from negative infinity to negative 5. And when is it decreasing? It would be decreasing on this section. And that would start at negative 5 until we go all the way to the right, which would be infinity. So this is intervals of increasing and decreasing. Right now we're just doing it with absolute value, but eventually we're going to do it with more complicated functions. So we could have a function like this. And the important part is going to be to find these extrema, these almost like vertices of the graph, where we have a max and a min. And let's just give another quick example here. Let's say that this is 2, 4, and maybe this is 6, negative 8. And when is this graph increasing? This graph is increasing on this section, and it's increasing on this section. So we would say that the intervals of increasing here would be from negative infinity to 2, union 6 to infinity. When is it decreasing? It's decreasing on this section, from the max all the way to the min. So it is decreasing from 2 all the way to 6. So again, notice that we're always using the x coordinates of the turning points to find the intervals of increasing and decreasing. Well, hopefully you found that helpful for finding intervals of increasing and decreasing. We'll see you here next time. Bye!